Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to DIY Metal Router 10. Today is Friday. I ship out tomorrow, so let's try to get quite a bit of this done before I ship out tomorrow. I'm heading into work at 10. Usually I'll do a 30-minute video and a 30-minute break, but we'll see. We'll see how far I get, so that will determine whether I take a break for work or if I go right through. I will probably have some time later on today, but we're going to be packing and parents and stuff are going to be running around and whatnot. So, and also my brother and Alana and my niece Ava is going to be also running around as well. So, probably not the best time to record. So we'll see. We'll see what we can do here. All right. So. Let's go ahead and, okay, so we got these two, right? These two are right next to each other, right? If not on top of each other, almost. Yeah, so let's hide this. Let's get these to where they're basically right on top of each other. Let's go into joints. So you can see the rail there. Call that good. All right, and then we're gonna do our standard driven. So rigid group, sure. Now, theoretically, so let's call this Z-axis. This is Z-axis driven. And then let's go ahead and do this. So this is X-axis group. This is Y-axis group. Cool deal. No, we don't need to do that. Okay, so let's go ahead and pop this guy back on. Actually, no, we won't do that. Let's do... no, we're just going to assume that they're touching. So, alright, so now let's go ahead and do the play. Oh, no, we need to do the custom clamp. And I need to bring up all, because this is a new day, I closed AliExpress, so let's go ahead and bring that back up. And this is zoomed in way too much. And we're going to say Hiwin HGH20CA. Why is it taking so long? I'm also taking off my jacket here, so there it goes. I think it's this one here. It's got the good image on it. Okay, good. Okay. All right, so same deal here. Actually, it's but now they're B instead of C here. So let's go ahead and go here, edit, And then this is B now, so a little bit over B. I would say we'd be safe if we did W, which is 44 divided by 2, so it's actually bigger. What? There you go. Because W is actually bigger than C, so alright, so that's what we're doing in actuality. So there we go. And then this guy, we could have it go down for a ways. So we're just going to say here L okay, so we need to do a little bit of math here. So L is the total length. So L is the total length. And we need to subtract L by L1 divided by 2 to figure out what that step height is. So L for this rail is 77.5 minus L1, which is 50.5. And then we're going to divide that by 2. And that's the total height. Now, that's that extra little piece. So we're going to do that plus L1 to get us kind of towards the ledge there. Because we don't want to do this too deep with a small end mill to get this to have a small radius corner. So L1 is 50.5. And that's 64 millimeters. Okay, so let's do it. Boom, 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 boom. And then this is 64 millimeters. 64 millimeters. And this is the top. Okay, so there's the top. So now it needs to go from basically that one distance that we did. So let's do this. So this was 13.5. So it has to go 13.5 plus another 13.5. Because it has to go from this one to this one. Right, so 13.5 here, 13.5 on the other one, and then it goes to L, and then that's extended for a certain amount of time. So 13.5 times 2 is 27. So what we're going to do is we're going to go here, and we're just going to put a circle here, and we're going to project this, and then this guy's going to come up solid for 17, or 27. All right, 2 times this, 27. So 27 millimeters. Okay. Oh, there's no hole. There you go. Okay, and then here, we're gonna look at this sketch. And then we're going to extrude up. The same deal. So this is going to be 64, 27. Oh. don't think that's right. What is this first one? .64. Okay, 64 millimeters. And there we go. And it has a small little piece there to push on the spindle. And that is the overall piece there. So let's go ahead and go bodies. Let's make this guy. Now here is the issue. How do we go about making this to where it's going to hold that thing? Are we going to do set screw? Me personally, I do like set screw to make this really, really tight and have some sort of notch here. But if we have a clamp here, we're going to hit the edge. Pretty much no matter where we put it, we're going to hit. Unless we're going to lose area no matter where we put it. So if we put it here, 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 so the only thing is set screw, or set screw. And we can't make this flexible because it has to maintain the holes. So maybe a set screw from the back and make this really, really tight tolerance, but this is pretty tall. Yeah, 6 inches, that's not bad. 3-inch down, 3-inch length of cut, that's no problem. So that's not a problem. 6 inches, that's quite a bit of almost this guy here. Let's take a look. Again, I'm probably not going to figure that out at this point. The main thing that I want to figure out before I have everything set up before I leave is that this stuff is that the stuff that I need to buy, I know what it is. You see what I'm saying? So I'm not too worried about getting this perfectly figured out because I just want to know the stuff that I'm going to buy. Obviously, I'm going to machine this, so I have time to figure this out. But the stuff I'm going to buy, I want to know. So we might even just, for the time being, well, it's going to be very, very quick to do this anyways. So let's go from here. So now we're going to make the holes for the brackets. So this is B divided by 2. So this is 6 millimeters divided by 2. That's not B. Oh, that's B1. It's 32 millimeters divided by 2. 0.63. 0.63. Oh, 0.63 inches. Okay, so now how did I calculate this again? I calculated it from being from this top, I believe. From this top position. I think. So that's L1 minus C divided by 2. Wait. Yes. Okay, L1 50.5 minus C 36 divided by 2. 7.25 millimeters. 7. And then this is C, 36 millimeters. Why is this so long? It's only supposed to be a little bit longer. We'll have to see. We'll see in a second. And then we're just going to mirror this. Let's do projection of the outside. Okay. This is a standard 6 millimeter. And there it is. How thick is this here? Yeah, that's okay. Okay, so that's good enough for right now. It's probably not right because I can't remember how I set it up. But just put it in there for shits and giggles. And as you can see, the holes do indeed not line up. So, let's do this one last time. Okay. So, this guy is indeed to the start of C, which is L minus C. So L divided by 2 minus C divided by 2. So L divided by 2, L is 77.5 minus, divided by 2 minus C divided by 2 minus 36. Equals 20.75. So this is 20.75 millimeters. That's okay. There we go, that's better. Well, that's doing it. Well, how much time do we have? We're at 20 minutes. Top left corner. Alright, so here we kind of see through the component. Bam, they line up. Obviously this one's slightly askew to one side, but they do line up, and they do just meet flush. Perfect. So now there is our spindle mount, and we're not going to lose any. We're not going to lose any distance. So let's go ahead and joint. And what I'm going to do is I'm going to joint this guy right to just popping out of the bottom. Because we want as much support as possible. And there we have it. There is our spindle. And another thing is, I think we might have a good enough design where the bolts will clear. Obviously we don't have a whole lot of thickness there, so we're going to need to have some very narrow-headed bolts, but because they're so far apart, they might clear regardless. But I do like it, so let's go ahead and put back the X-gantry plate, and that's jointed. So now that we basically have majority of the stuff there, obviously what we're missing is some of the drivers, like for example here, a screw going across here, which I'm still thinking about how we're actually going to do that. We'll probably have it somewhere in the middle to kind of hold it up. So we'll have the screw in the middle to hold it up. I mean, it's being held here, and it's going to be held here, and then there's going to be a screw going across that will hold this up, and then hold the spindle up. Right, so we might have, what we might do on this guy is we might put a little bracket on the top here in the middle, so as it goes here, it'll cover it. But another issue that I see now is that we're going to lose a lot if we support it from the other side. So maybe instead of supporting it from the other side with a rail, let's support it from the other side with the screw so we don't lose so much here. Because obviously once this guy hits the end, that's it. You can't go any further. And we don't want to lose too much more than 45, because here we're already basically at the edge. So it's from here, but obviously here that's okay, because we have to have somewhere to put the fourth axis. So if we can't get over here, that's not that big of an issue, because eventually I would like to have 2 fourth axis and then the rest of the stuff over here. And then this is 10 inches in, and then you have another 15 inches to store other things. Which there's only 2 other parts. There's the side walls and then the half moons that are rest. Oh, and then the gears, of course. So we have to have a little section for the gears. Okay, so that looks really good. I mean, at this point, I would like to do some stress analysis to kind of figure out how this is looking. Because, again, I'm thinking that we're probably not going to go with the rail. We're just going to put a ball screw through here. And then this guy will be supported up with the ball screw. Ooh, but it has to be basically touching this, because it can't be touching that, because that's moving. Unless there's a rail here. And then that's the other thing. How are we going to have this guy supported going? How are we going to have this guy go up and down? Put the motor up over here, and then have a little thread going down through this edge here. I mean, we could do that, or this thing is offset over here, and then we have the ball screw coming down through here. This guy offset, ball screw coming down right here. Obviously, I would kind of like it to be over here somewhere. And I would like the ball screw to come across and support it. But let's go ahead and drive it out. And while I'm thinking about that, let's go ahead. Obviously, some of these parts are different. It's actually going to be, so let's do everything mid travel. Let's drive this axis. There's mid travel. Then we're going to go mid Z. So let's pop the Y out, or the X. Not that one, this one. Alright. So let's go ahead and put this on here. Let's go ahead and save it. Let's go to the stresses. Stresses, study, static stress. Alright, now let's go ahead and look at, oh, it said something, I didn't see what it said. Let's go ahead and look at degree of freedom view. Everything is free for the most part, so let's do some automatic contacts. Let's see, it might get pissed off because of my gantry. Uh-oh. Okay, so let's just put the ground contact, the ground contact first, and then look at the DOF view. Okay, so there's fully fixed. Now we need to do contacts with respect to everything. So let's do almost like 1 millimeter. Oh, and it says this, partially free, partially fixed, fully fixed. It's really strange. Probably have to figure that out off camera here, why it wants to do that. But let's put, it's right now let's put a load. I mean, I haven't done loads in a while. So let's put a load here. I don't know how big of a fan I am of that thing being cantilevered, that rail being cantilevered out. Oops. Turn off all bodies. There we go. And then let's call this is supposed to just be 5 pounds. Five pounds of cutting force. And for whatever reason, does not want to generate contacts. Oh. All right. Okay. Hopefully no issues too much. Oh, I thought I told local. Anyways. So while it's doing that, I'm gonna go ahead and get changed, and we'll just keep going on this video, because I'll probably take a break for work. I mean, it's getting close to work time anyways. So we're just gonna wait for this simulation to complete to kind of get an idea of what this is gonna look like. Also, another thing this weekend, which is the weekend that obviously I'm going to Hawaii. I want to keep up with the uploads. So I'm going to be mainly working on this Green Engineer stuff. Oh, it's in fail. Uh-oh. Let's see. Oops. Okay, so what we're gonna do, so basically what we're gonna do, let's just change the loads one more time, and then if that's the case, I'm basically gonna have to go and edit. So let's say this is 5.5. What's the warning? Let's solve locally. Alright. So let's have the Green Engineer PC do some work on it. It's probably gonna fail meshing again. And then I'm gonna probably have to do stuff off of recording to fix that. But it gives me some time to get changed for work, so there is that. Okay, let's see if it fails meshing. Looks good so far. No, failed meshing. Okay, so does not like that. Does not like something on there. Alright, well, I mean, obviously can't fix it right now. We're over time. I'll have to fix it later. Alright, so I'll figure this out so we could do testing. I mean, even if we don't do testing, I think it's going to be pretty good. Pretty strong. So I'm not too worried about it. But I think that this will be fine. We'll shorten this up. But I think it's just big enough to fit another one here. So we might just have the motor here with the screw going across here somehow. And then we'll put some sort of mount something here or something. And then this will have some sort of little flat bar mount or something to have this screw. Well, you can't do it here. You have to do it off of this rail. So, or the screw could go underneath. That's actually a better idea. I like that idea. The screw go here and the screw go underneath in between here. And then the other screw, maybe put it over here. And then this bracket could go off the edge. Because that's not going to limit. I mean, obviously this bracket being over here is going to limit. But I think this if we have to make this wider, basically this will hover off the edge. So we'll have two of these guys, and then this guy could go hover over off the edge. So I think we're looking good. So put the screw underneath here, because that screw obviously is just going to have to attach these two pieces. For this, it's not gonna, but this one I want it to kind of help it support it a little bit. So if I have the Z, it'll hold it up on this edge, which is basically the same as this guy over here is holding it up. But really, nothing here is holding it up. Really, the screw is what's holding it up. So maybe even have it over here at the base will probably be just okay. I mean, we'll have it right here. It would be really close, and we offset it so we're not losing any space. So we have it here and here, and then we make this guy really, really close, and we get back some room. That's pretty much what I think we're going to do. Alright, so we are over time here. This has been Steven from Legit Tech Tutorials and the Green Engineers. I'll probably be back later on tonight to try to fix this up as much as possible before I leave. We'll probably not get the stress analysis to work, so we're going to have in time, so we'll have to assume that it works, and then I'll have to mess around with that a little bit, maybe in Hawaii with my really crappy laptop, or I'll use my my work laptop, as that's way better. So when I get that to work, I'll come back and tell you basically what I did to get that to work. And then, like I said, add another carriage down here on the Y, and then move this over, put the screw down here, and then have the other screw clear this bracket here. And that's pretty much it. So this has been Steven from Legit Tech Tutorials and the Green Engineers. I thank you guys for watching episode 10 of DIY Metal Router 2. We're getting really, really close to completing. We just need to now do some fixes, add some more strength, and we need to add the actual motors that are going to do this sort of motion. I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.